What's up, everybody? For those of you, all 19 of my subscribers, but hey, that's cool. It'll grow at some point, I think. Maybe. Who knows? I really don't care. But yeah, for those of you that are turning in, we have updated some of our cameras. We have updated some of our technology. We're running this pretty sweet little OBS bot Tiny 2 with, make sure everything's going, with tracking. And so this one is kind of interesting because it's be able to track me around the garage as I continue to work on things. So as we work on things at workbench, we can like reference over to the camera over there. Meanwhile, I got one of my other cameras still hooked up, and that's going to be one of the GoPro's Hero 11s with the Media Mod and a few other things. And so, yeah, lots of camera control going on, lots of changes that are happening technology-wise around the garage. And so, still kicking the wireless microphone from Jay. Jay, thank you so much. You are awesome, and hope to pick your brain on some other stuff here in the near future. But the tracking thing is kind of interesting because it's like it's gonna follow me around, and it's really kind of cool. But yeah, getting it played in, printed out a bracket last night, or started the design of the bracket last night. Went through a few different design iteration changes, and we have the final production bracket, which the camera is attached to right now. And it's actually inverted and inverted from its normal fashion. So it's actually panning kind of like what you would have on an aircraft for like a pod that would be like looking at the ground. And so it's a reverse mounted camera. And yeah, it's tracking very well. It'll track me all the way across the garage. But what I do like is having like preset features. And so when we change the camera angle, I can go ahead and have it go to specific presets. Like preset 2 is over to workbench. Preset 1 is like tracking me around. And then preset 3 is actually over here. Once we have the 3D printers, it'll be 1, 2, 3, 4, all on the workbench right here. And so we can track jobs or whichever we're going to be doing. And so, yeah, I'm waiting for another shipment of filament to get in so we could start working on some more prints and get a few things out for the brewery and whatnot. Yeah, pretty cool stuff. And so the reason why is one of my GoPros ended up dying over the weekend, and because it did die, I had to come up with a replacement solution for it, and did some research, and I thought the panning feature of the Tiny 2 would be kind of cool. And so that's why we are able to work kind of the panning around the garage and working through these things. But it's weird because I have a camera over here pointing this way, I've got a camera over here pointing down, and I've got this one that's going to be able to track me around the garage as we continue to do work. And so yeah, lots of changes on that front. A little bit of debugging, but now that the debugging is kind of out of the way, we're just kind of getting right into back to recording and production. So yeah, we'll kick this one back over to preset 1. Sorry, over to preset 2, I mean over to the workbench, because I don't think you guys want to stare at my back the entire time that we're doing things. And so we're going to continue to work on some refinement and in Orca Slicer to get the calibration out. So we did a temperature tower. We came up with 210 being the best, and so we went with the high end of 205 with the low end of 215, or low end of 205 with the high end of 215, with medium ground being 210 for the best clarity. And then I did retraction towers on it, and so we did a flow rate pass 1 and pass 2, which is the default flow rate is fine. And so pressure advance was fine. We did the retraction test was fine, and so getting into the Orca tolerance test. And so this will be the next print we're going to have going out, and so we'll see how it goes with the tolerance test. Just make sure that everything is fine. Question mark. So with the default portfolio and profile we have, we could go to the, I think I was doing most of the edits on the 0.6 Z hop. So if we slice this one, and the 0.6 Z hop was for some of the beaked flutes, also known as the recorders that I was working on. And so we're just going to run the tolerance test real quick. And we're going to send that to the bamboo. We're not on the cool plate though. Cancel that. We are on the texture PEI. We're on the X1 carbon. I don't know why that was set to the 0.6. So maybe I do need to add this. Maybe this is the X1C. It should be the X1E. It should be the X1C. Oh gosh. Now I'm just confusing myself. So let me take a look at the multimedia extruder 0.4. Traction 0.8. C-hop 0.6. Let's see. That's fine. Now we need to go down here to MHPIL, PLA, X1. And we want to check our filament. 210, 210, 215, 205. Cooling, setting override. 0.6 C-hop when retracting. Okay, that's fine. Okay. Slice. We're not on the cool plate. We are on the texture PEI. Slice. 15 minutes, and then we'll send that to machine 2. So all of this is in hopes that we can nickel and dime down some of our print settings with the bamboo, not the bamboo, but the Manor Hackers brand of filaments to get them printing as well as the bamboo filaments. And so we're just running calibration after calibration. And I got to debug NVIDIA broadcast because NVIDIA broadcast, I was having a couple headaches earlier. I got NVIDIA broadcast to be like synced with all the different things that I got going on. Well, that's going to be microphones, inputs, cameras. I may have to get with Jay and sit down and get it really, truly debugged for the build. So it's yes, yes, that's fine. I know. Okay. It's just telling me that the camera was last active for the Bamboo Studio versus Orca Slicer. Neither here nor there. It's all gravy. It's all gravy. We are working through some of these little nuances, and so we also adjusted our stream deck to account for the OBS Center and how OBS Center is going to be working. For the camera control for the OBS bot camera. Okay, moving right along. Now I got this next configuration one running. We're going to do the same process on our other bamboo that we did for the first bamboo. And here's some sections of my beautiful arm for my overhead camera that I don't need this section anymore. But we're going to save these 3D printed parts and components because I don't like getting rid of things, as I am a pack rat. Because there might be some obscure use and need that I have for that thing in the distant future, whatever that future may be. Yeah, things are getting crazy. I'm kind of crazy, what can I say? Alright. So, anywho, but the good news is that, you know, these cameras don't have that crazy delay that I was having with previous iterations using using the RTMP server through the GoPro. I did. This is an interesting noise. I think it was just jettisoning some filament because it's going through its purge cycle. But no, had some interesting thought put to a few different facets, but you can see our hanger for the camera. Here's a couple of the different design iterations. Now these are no longer needed. I went through 4 iterations before I got one that is fully up and running. There's actually a 5th one, but I'm not printing it out yet because I don't have a need for it. Everything else seems to be running fine. So we're getting right into it today, where we're just going to try to get things back on track with getting ready to launch the nonprofit, getting some of these printers into maintenance, getting them synced and up and running and back into production. But yeah, zip this down, get that set of pliers out, put some stuff away into the cabinets. The background noise isn't too bad. Seems like it's not, but you never know. NVIDIA broadcast is still having a heart attack. Okay, so what we're going to do is we're going to jump in here, and then, let's see, what was it? It was the, oh gosh. Did I bookmark it? I don't think I bookmarked it. It might be on my other window, so we're going to jump over to my other account real quick. And then it was, and extrude, yep, this one we're going to Google search. So we're going to take this, we're going to close that window out, go to this window, pop that in, go in here, solutions for Z-axis screws. And so this is my concern with some of the ringing that I was getting, is that there's maybe too much deviation from the bed from a couple different crashes that I had. And so it's really, we're not working on resetting the Z timing and the pulleys, but we are going to get into section 2, or option 2, or operation 2. So we got the glass plate removed. That's actually over there on a workbench right now. And clean off the base of the printer. And so, yep, we've already cleaned out the base of the printer. I did that last night. So we're going to lock the Z-axis sliders, and so we're going to put the unit on its side. And so what I'm first going to do is I'm going to remove the screen, because we're going to turn the unit upside down here in a little bit. So we're going to remove the screen. And it's funny looking at the generations of the cable and everything. Did not mean to knock that over. Screen off to the side. Up here where I deem it is safe, kind of, question mark. Alright, so what we're going to do is we're going to turn the unit all the way upside down. Leaving these PTFE2s for the MS hub intact. Turn the unit over. Not anything else that's crazy. Shake out of it. And we're going to lower the unit all the way down until it completely bottoms out. Okay, so there's bottomed out. And you can see that there's been some like rubbing and wear and tear on the belts themselves. And so there's been some rubbing on the belts. You got rubbing here, rubbing here, and so there's been some rubbing going on, which makes me wonder if one of the idlers is off or if we need to adjust some stuff to get these back into sequence. And so now that it's all the way to the bottom, what we're going to do is we're going to take the unit and we're going to flip it back onto its top. I'm going to grab and lock down the bed. So we'll move this back over here. And so we're going to take the factory screws in. I can see that there's a little bit of gapping on this side versus no gapping on this side. So this is going to all get it cleaned up. And so we're going to lock back down the bed. Back to it's kind of like how they did it from the factory, you know. I don't know if I'm necessarily going to lock down the back one. I probably should. Just for sanity's sake. I'm kind of insane. Kind of crazy. Kind of crazy. Just a little crazy. Not a lot of crazy, just a little crazy. These little bits that have fallen out of it. Toss those in my recycle box. Once I go and put together a filament grinder and re-extruder. I want to make my own filament out of all that waste. Again, kind of crazy, just saying. Alright, so we're going to get in here. Alright, now that we have all three of the Z factory locking positions down. Turn the unit onto its side. I shouldn't be putting pressure like that on the glass plate, so my bad on that. So alright, so what we're going to do is we're going to release the tension, so we're going to put it back all the way up actually. So we're going to release the tension base off the tensioner screw. We're going to ever so slightly loosen up the pulley, the tensioner pulley. And what we're going to do is we're going to hold tension on each one of the Z screws. I'm actually going to pop one of these out and over. Place all the tension on it. If I could get that to happen, that'd be great. And so it should be anti-clockwise to get it down. Come on. You can pop over. Come on, belt. If I could get the belt to pop over. What we'll do is we'll so we want these rotated completely as far counterclockwise as I can get them. And what I might do is I might try to pop it over the drive gear. Man, that belt is still tight. Come on, belt. Once I have those tension, what we're going to do is we're going to basically we're compressing the build plate all the way up against the plastic here. And so now we're going to go through and we're going to lock down the 3 screws from underneath, and then we're going to retension everything. Alright, that's done. I'm going to retension the belt system. And so hopefully this will alleviate some of your guys' belt ringing. I know my belt ringing was getting rather terrible. And it could be that just the unit just isn't square. You know, if that's from shipping or from transport or what's causing it not to be square. But you can see there's that little bit of a rocking motion in there. So the unit isn't like completely square. Alright, once we have those tensioned, I'm going to check to make sure there's no looseness on the idlers, on the pulleys. We could test all those. I'm going to cinch this guy back down right quick though. Alright. Good enough for government work. Now that those are done, we're going to flip it over and we're going to remove the 3 locking screws. What if it's one of the panels is just slightly out of square? I don't know. So we got a little tolerance check, cool down. I'm going to take that a quarter turn, take it back 1/4 turn, take the front 1/4 turn to relieve the tension, and then we're going to zip these out. By zip them out, I mean I'm just going to hand turn them out. Probably shift this back so you guys can see. I have a drawer of just nothing but bamboo stuff. Alright, now that those are out, I'm going to put the unit on its side. We're manually going to bring up the bed ever so slightly. And there's some plastic debris that came out of it when we had it upside down, so we'll throw that into our recycle bin. And from here, grab our texture PEI plate, put this bad Larry back in. Alright, grab our screen. Oh, come on. It's really hard to get the fingers in here. Alright, once the screen's connected, we're going to pop that back into its spot. And then to release the screen, there's a little dimple on the bottom. You press up and you just rotate it, or push it to the right, and it'll unlock, and lock it back down. Because you'll have to take the screen off when you flip the unit upside down so you can access everything. And you can see on here, I also have these little handy dandy guides that's on top of the PTFE, and this is really to help alleviate it rubbing across the glass and like putting shards of Teflon all through the unit, because I don't like having Teflon inside of it. You know, neither here nor there. Once that's done, we're going to go ahead and grab the glass top. Put the glass top back on, and we're going to go get this printer back into calibration and then back into printing. So this one's kind of unique because I do have the E3D high flow nozzle installed on it. So the high flow is kind of nice. I'm going to check our tolerance test real quick. Still cooling down. And we we do have some ugly stringing in here, and we'll show some of that. So we do have some stringing that's going along inside here for the tolerance test. That's probably attributed to temperature and the retraction that I was adjusting. So 0.4 is good. 0.3 is good. 0.2 is good. 0.1 is good. Come on. 0.1's a little sticky. Or 0.05 is pretty. 0.05 is tight, which is fine. And so then I'm just doing a pressing through the tolerance test. And then down to the 0. And so the 0 should literally just snap into place. And so, I mean, from a tolerance perspective, tolerances are good. Because it snapped into place on the 0. So we did that, we did that, we did that. That's the one thing I didn't do is that, so we're going to go ahead and I didn't cycle it before retensioning it, so because I skipped ahead. So I'm going to disconnect the screen again. Remove the glass plate. Turn the unit back upside down. Hardened plastic boogers from all the prints I've been doing. So this is my bamboo that's over a year old right now. And I haven't had too many issues with it whatsoever. Still has that crazy rocking motion. But that's okay. We're all kind of crazy. You always got to have a little bit of crazy in you. So we're going to loosen that back up. We're actually going to cycle this back and forth. So 1, 2, 3, 4. So we're just retensioning the resting position for the idler pulley, or the tensioner pulley, I should say. So now we're going to flip it back over. We're going to reverse the steps that we just did. Okay. All right. Now we're going to grab the glass top and put the glass top on. And now we're going to grab the screen and we're going to reattach the screen. Super exciting stuff. Pay no attention to me, I'm an idiot. It's hard to get my fat fingers in here. It's like trying to line it up in the dark. When I stare at lights. Alright. Screen is reconnected. Lock that back in place. Now we'll move back over to the workbench. You can see all those scarring marks from Teflon before I installed that adapter. Alright. so our tolerance test is good. Now we're going to move on to running some. What are we running next? We'll get the next test going, and then we'll get this thing on the workbench for bamboo number 1. Alright, so prep. That's fine. Calibration. So tolerance test is good. Max flow rate. Okay. So here's our max flow. I'm going to slice this. And I'm going to check the flow rate. And so as you can see, here's our variation in the flows that we're going to be looking at. And so if we go down, and so we got 0, and you can see it's increasing the flow, and so this is going to be layer 0.32. That's 1, 2, 3, 4, 5, 6. So every 5th layer, it's going to be ramping up. 1, 2, 3, 4, 5, 6. And so it's changing the volumetric level of flow for each one of these layers. So you got 2.29 all the way up to 20.62. And I need to run this test on the E3D nozzle, because the E3D nozzle is going to be the one that's going to be most impactful. Because normally it's like your standard, I believe is 12.36 or 12.63, somewhere in there, for the typical flow rate for the bamboo with the stock 0.4 nozzle. But the nozzle that we have installed on this one that's on the workbench right now, that's running the high flow, and so the volumetric amount of material going through it is 3-fold what the factory hot end is. And so those will be a little bit different when we get into calibrating this unit here in a few minutes. So that looks fine. We're going to go ahead, and as you can see, it's like we're looking at jumping between 4.58 all the way up to 6.04, 458, 1604 for the calibration for its flow when it's doing its sensor calibration at the beginning of the print. Let me take this all the way back. So it's doing its flow calibration there. That's the most interesting part about it. So anyway, we're just going to go ahead and get right into the print. And we will do the flow dynamics calibration. And in fact, let me in the max volumetric speed. So let's see what it says. So jump into a new window right quick. Orca slicer max volumetric speed. Yep. Let's see. Slice and print. Analyzing the results. This is where we're going to pick up. And so we're going to be looking for, critical areas of under extrusion or other quality issues, because that's what we're running into with some of the prints we've been doing. And we're going to measure the critical points, and then we're going to calculate. So we may get into this if it's going to work. And so here's the calcs for it. Of course, we can jump into ChatGPT and have ChatGPT kind of help us out with getting some of these set up as needed. We're just going to let it run for the print right now. It's just, let's see if we get down here to let's see, there's no best setup for it. So I guess we'll just run the extrusion calibration on the front end, and then the G code will take over after that. So yep, I'm gonna just go ahead and send this. Slam some more delicious frosty cold beverage coming out of the kegerator. All right, clean off the workbench right quick. And Bamboozle 1 is going back into its home. There is one thing I want to check beforehand, and that's going to be the idlers. I'm going to check the idlers, the tension idler pulley. So I'm just seeing if it's tracking up or down. And so that's, and so what I'm going to do first is I'm going to take a look at the motors. I'm going to see if the belt is tracking up or down on the motors. And I don't see any vertical tracking. So what I mean by belt tracking is the belt if it's on the gearing, and as I rotate the belt, I'm looking to see if the belt's rising or lowering on the knurling for the gearing. Let's attach the motor. And we're going to do the same thing on the back where the pulley assemblies are at. Got some extra light. Now I want to see if these belts are riding up or down, or if they're on top of, because I don't want to have these systems at a slight cant. So I'm not seeing anything dramatic. So we're going to call that fine. Now we're going to throw the last plate back on top and move this printer back into position and start hooking up all the PTFE tubes from the 4 AMSs. And we'll get this thing ready to start back into printing and run through some calibrations. All right. Number next. These two are going to get hooked up here and here. Doesn't matter which orientation or which one gets plugged into what, because they all feed into the same spot. It doesn't really matter. Okay. Bring these empty spools over here. Now we're going to go and check this out. We're going to go over to preset number 2. Or preset number 3. Boop. Look at that. So we're going to grab our PTFE tubing. We're going to route those up behind the shelf. And we're going to get these connected to the 2 AMSs that I have over here. So one's going to get connected here. Tell me that PTFE tube fell down. You suck. Alright, come back up. And I need a step ladder for this one. Gotta tuck this underneath so it doesn't fall down again. Okay. It's getting warm in here. Grab our Steppius Stulius. And get that connected into the PTFE coupler. Got those cables underneath. And we're going to slide this EMS back into position. Ta-da! Alright. Now, connect back up to power. And fire up Bamboozle number 1. And start running through the exact same calibration steps as we did for the other bamboo. Except we do have to connect our power for the AMS. I had some weird errors with the AMS, where there would be a loss of synchronization between the AMSs until I came back and played with the Come on. Why do you not want to go in? And so I checked the pin in, pin out the other day. It was fine. That's set. Grab our actual power cable. And plug you in. Back in your box. Turn you on first, though. All right. Now I'll let Bamboozle number 1 start back up. It's getting warm in here, so we're going to open up the garage door for just a few minutes. Hopefully we don't get too many bugs coming in here, but you get a thermometer in here or something. Because it is pretty toasty in here, just saying. Instant cold air. To our utilities, and we're going to calibrate, and we're just going to do bed leveling start calibration. And so long as bed calibration doesn't come up with any crazy errors, we're good. And so basically what we did is we reset the Z screw height. And after resetting the Z screw height, we're getting into recalibration of this bamboo, whereas this one's still undergoing current calibration. What's going to be unique about this one, again, it has a E3D high flow installed on it currently. versus the factory hot end. And so once I get some more bamboo material in, I'm going to run some testing between the E3D high flow versus the factory bamboo 0.4, because I was playing around with it the other day, and it turned out to be pretty interesting in the fashion that the factory E3D, or the factory 0.4 nozzle with bamboo filament was outperforming the speed of the E3D high flow with generic Matter Hackers branded filament. And again, here's the error that I'm having with the AMS hub is I'm getting a sequence red light on all of the AMSs. Now if I go through and I play around with the cables, and I think I may have like a cable error, or maybe it's the AMS hub that's failing, I'm not sure which, but it's rendering an error. Which is rather unfortunate. And it's like if I go back and I go to the back of the unit and I jiggle the cables around, it ends up being fine again. And so I got to figure out which is the first AMS in the sequence, because I think maybe that's where my problem is at. Because just the regular is not doing anything. I'm not sure why. But I got a bunch of different stuff in. I got a red, green, blue sequence coming in, and I've got a CMY coming in with some black and some silver from bamboo. Because I've had some better results with the bamboo filament over the Matter Hackers filament until I can get like the settings and everything dialed in for the Matter Hackers filament. Generally, I've just been running like the generic profile for PLA, and I'm getting some kind of results. And so it's been playing around with it to kind of come up with what's going to be the best option moving forward, whether it's sticking with Matter Hacker stuff or whether it's going to be sort of swapping everything over direct to the bamboo filament and running bamboo filament with the refillable spools. I'm just going to have the RFID stuff just because it's like the RFID and those bamboo filaments, having them kind of almost tuned. And this, I guess that's the best terminology for it, is they're just tuned better. And so having tuned filaments on the printer seems to be working better. And so that's my hope with all of these testing and evaluations, is running tuning. And so bamboo did not pop any errors up with the bed leveling. And so we're going to run a quick test. But it's not going to work because we received that AMS error. So I'm going to come back here. Okay, so it looks like it's my 4-pin cable is what's inducing the error, because as soon as I started jiggling the 4-pin cable around, it removed the error. So bamboo number 2. Well, there we go. There's the error again. Yeah, my 4-pin cable is not flying. I do have some spare cables at the office. I don't think I have any spares here, I took them back into the office the other day. Why are you freaking out? So disconnect that, reseat that. Technically, I do have another 4-pin cable here, which is on the back of this unit, and so I might pull that 4-pin cable off. comes up, we're white across the board. And then back to all 4 flashing red. So, another thing I gotta figure out. All right. I'm just gonna hold pressure on for a second. Alright, so as long as I keep pressure on it, it's working fine. Alright, so if I let Alright. It's so far away. So I'm going to release pressure on the back of the cable. We'll see what happens. And so if that's my guess, it's like I guess I have a bad cable. Yep. And so it popped up the error where I got 4 flashing red lights. So we're going to put pressure back on the cable. Release pressure. See, it goes back into the communication error. Yep, there's communication error, so interesting. So we're going to do what any red-blooded American would do, and we're going to fix it with some tape. blue painter's tape. Works wonders for everything. So what I'm going to do is I'm going to tape the cable. Ta-da! Hopefully that doesn't give us another error. We'll see. Oh, there's the error. Dang it. And I don't know if it's a problem with the connectors that are on there, but that little bit of jostling seemed to have helped. Let's see if I move it back, it's going to error on me. Yep, it errored. Alright, so I'm going to pull that. This is fun. Because you can't print in 16 colors without a good AMS. You can't print it all without, you know, I could disconnect the AMS and then hook it up. Let's see. All my bamboo spares are at the office. Okay. How do we rectify this problem? This problem. And I don't even know why it's having an issue. As soon as I push, disconnect the cable on itself. Alright, so here is our 4-pin cable. So our 4-pin cable is the one we're having problems with right now. And let's kick this over to reset 2. So this is the cable we're having problems with. And it's not necessarily on this side, it's something with this side of the connector. It is not making a good electrical contact unless I'm putting pressure one way or the other. So I don't know if it's that there's a pin out issue on the X1C. If one of the pins have been recessed even more than it should be, or that just I'm not getting good electrical contact on one of these 4 pins. And I don't see anything glaringly obvious. And so I'm using my phone magnifying glass because what I'm going to do is I'm going to take a picture of it. I'm going to go to the picture and we're going to zoom in. So not the best picture. I'm going to zoom out and go back to our camera. Alright. So as you can see, it is a little bit chewed up on some of the connectors, and so I think we may need to just get a new for this one. I've got, like I said, I've got some spares at the office from my AMS kits that I've had. It's just super weird that I'm getting this problem, because this cable hasn't really been changed or shifted in over a year. I mean, seriously, come on. Thank you. And it only seems to be when I take pressure off of it. And so it's not making strong electrical contact. So they're flashing on all. I just tap the cable ever so slightly. It goes back to white. Now it's going to kick back into the communication error here in a little bit. So I don't know if my AMS hub is bad or what. I don't know what's going on with this thing. I'd like to figure it out though. What's crazy is if I push on it, as soon as I bump the cable, it fires right up. So, yeah, this is an interesting one. Let's see here. So I have heard that people have been functional and good with connecting the AMS hub to a single and then splicing. So we're just going to see what happens. I'm going to check the cable through our default hub that came with the printer, not so the AMS buffer, not the AMS hub. And see what happens with the AMS buffer. And so I think my AMS hub may be shot. Yeah, so I think my AMS hub is shot, because the regular AMS buffer is working just fine through it. Which really sucks. So I wonder if we jump into OBS Studio right quick. So I don't know what the reason is that the AMS hub versus the AMS buffer needs to be attached, because if we go here, we go to device, we go to machine 1, and we check our filaments. And the standard AMS hub is showing that here's all of our loaded filaments. So it's recognizing them all. You broke off. Yeah, you snapped a bunch of material off me too. Awesome. I've been having some problems with some of the bamboo filament where it snaps off inside the PTFE tubing during the routing, so it's kind of a pain in the butt to deal with. And so we're going to pop the AMS hub off the back of this unit, because that seems to be a root of all of our problems right now. EMS hub's doing just fine, so I don't know what's going on with this darn thing. Here we go. I'm not worried about voiding the warranty at this point. Just want to get this thing back up into service where it will be functional. I'm just kind of curious to see why there's so many additional electrical components that go into the EMS hub versus the regular EMS guide. And so we're going to take a look at the pins. And so I think that's our problem right there. There is some discretionary play in the mounting bracket. A lot of discretionary play. So we're actually going to pop this off. I'm going to check the actual electrical connections themselves. Come on. Does not want to budge, does it? The EMS buffer is operating just fine, which tells me that it's not the cable. It's somewhere where the cable is connecting. You get one of those little magnifying glasses. So I think it's going to be an issue with one of these little joints. It might be that I could just resolder those little connectors if I could get this thing out. Yeah, there it is. That's what it is right there. So this pin, this lower pin right here is completely loose. Both lower pins are completely loose. And so I think I should be able to touch that up with a little bit of solder. And I need some glasses. And so these bottom two pins, and this is where I've been having problems, is these bottom two pins are completely loose. Like, not even making contact. That's why it's making contact for a split second and then it's shorting out. That's crazy. Upper two pins seem fine. And so we might touch these up with a little bit of solder. This connector is really tight too. Yeah, I broke off the little nubbins, but I really don't care about the little nubbins at this point. Just want to get this thing back into service. Interesting. So we take a look at it. You can see these bottom two pins. So this pin and this pin, those are the two that have failed on the AMS hub. We're going to try to get these routed back through, and if we can't, I'll work on it later. If we can, that'd be great. God bless America, I just need to be able to see. Don't get old. Your eyesight starts to go and it really sucks. That's my advice to all you youngsters that are out there. Don't get old. For all of you that already have bad eyesight, I feel your pain. Need like a magnifying glass to work on this thing. So we're going to take it. Up. Oh my Lord. Okay.
might do is I might pull the soldering iron out and loosen the solder up on all 4 of these. Pop the entire bracket out and then re-solder it back into place. So here is a weak point of the AMS hub that we have identified, is that their connectors suck. There's the first 2 on. All right. First 2 are really easy to get in, the upper 2. The other 2, not so much. we're just going to go ahead and pop these guys out. One, two, three, four. So the AMS hub is going to be completely repairable. It's just dealing with some issues. Okay. You need like a magnifying glass to get through this shit. Part of my language. There's that weak solder joint. Alright. So what it is, we're just going to reset it. Let's grab a soldering iron. Let's grab an extension cord. Soldering iron cooking. Grab some solder. Holder. Get some beer. It's probably not helping with my eyesight whatsoever. Alright. Close. And so, I mean, that thing came out really, really clean. Really clean. Again. Maybe some very, very slight extrusion at the very, very top. So what we're going to do is we're going to pop all the pins out. always funny because just touching these things has stiffened them up already. Come on. That solder just does not want to let loose. I'm putting some pretty good pressure on it. It just does not want to come up. Should not be this difficult. All right, there's one. There's two. There's three. more so snapped it off than anything. Good night. So we're going to take a look at our other EMS buffer to figure out positioning for these guys. And hell, I might just take one of these apart and just cannibalize this connector off of it. So it's the same damn thing. Part of my language. So it should go So we should be going short and stubby into that one. Okay, I should be going short and stubby into this one. All right, short and stubby, short and stubby. So this is the one I have in question right now, is this guy. Because that one snapped off, that one's going to be the one that's going to be the most difficult to resolder. And this last one. All right. 2:23 in the morning. How did it get to be 2:23 in the morning? Lordy. Pull out my vise. Drive me bonkers right now. Move this camera a little bit. Go boop. Let's get right over the top of what we got going on. That's what you call bamboo repair extraordinaire. All right. My ghetto light tower. Okay. Bless America. And I say it again, kids, don't get old. This not being able to see is kind of not very fun. I can't see. Ooh. Just zoom in. God bless America. toasty. I might try this again tomorrow because it's late. And I'm just not getting any solder out of this darn thing. I have to cool down so I can take some steel wool through it or something. Well, do what everybody else has done and just use their AMS hub, just route off the board. Anyway, oh lordy. Yeah, we'll just go ahead and shut everything down for the night. I'm tired of fiddling with it. We'll come back tomorrow. We'll keep crushing it. We'll get a solution. Anyway, I'll catch you guys later on. My eyesight to come back is what I need.